The European Extremely Large Telescope, or E-ELT for short, will be by far the largest optical and near-infrared telescope in the world. In early December 2014, the ESO Council gave the go-ahead for the first construction phase of the telescope.
This is the ESOcast. Cutting-edge science and life behind the scenes at ESO, the European Southern Observatory.
Astronomy has reached a point where bigger telescopes, much bigger telescopes, are essential to address many of the important unanswered questions. For nearly a decade, ESO has been working together with its user community of European scientists to design such a new giant, the E-ELT. The decision by the ESO Council means that crucial contracts, including those for the construction of the dome and the telescope structure, can be awarded according to plan. The E-ELT will have a main mirror 39 meters across. It will collect 13 times more light than any other optical telescope today. This main mirror will not be a single mirror. Instead, it will consist of 798 hexagonal mirror segments, each about 1.4 meters across, but only 5 centimeters thick. The E-ELT has an unusual optical design, using 5 mirrors. This includes advanced adaptive optics that corrects the fuzziness of astronomical images that is caused by atmospheric turbulence. Adaptive optics are already in use at ESO's Very Large Telescope. By using this technique, the E-ELT will be able to produce images up to 15 times sharper than those from the Hubble Space Telescope. The E-ELT will feature a suite of state-of-the-art science instruments to capture the light that the telescope collects. The dome of the E-ELT is an exercise in superlatives. With a height of 74 meters and a diameter of 86 meters, it simply dwarfs any existing telescope enclosure. The perfect future home for the E-ELT has been found on the summit of Cerro Armazones, a 3,000-meter high mountain only 20 kilometers from ESO's Paranal Observatory in northern Chile. On the 19th of June 2014, part of the peak of Cerro Armazones was blasted away as an initial step towards leveling the summit. Since then, the work on the mountain, as well as on the road from Paranal to Armazones, has progressed well. The construction of the telescope itself will take about a decade. Once in operation, the E-ELT will tackle some of the biggest scientific challenges of our time. It will image planets around other stars and study their atmospheres looking for biosignatures. The E-ELT will also make fundamental contributions to cosmology by measuring the properties of the first stars and galaxies in the universe and by probing the nature of the mysterious dark matter and dark energy. On top of this, astronomers are also, in a way, expecting the unexpected. Surprising results that cannot be anticipated today. The European Extremely Large